Hello everybody, my name is Thomas Kim. Today is July 5th, 2022. This is my 22nd episode about C++ 17 2023 CodeSQL OpenGL OpenCL TBB. This is the first episode for oneTBB. The title of this video, It oneTBB Raw Digest as do boa constrictors. I am not talking about boa constrictor that looks like this, not that of Little Prince. I'm not talking about such boa constrictor. I'm talking about such boa constrictor. Wow, they are so scary. We will run concurrent map or concurrent unordered map to debug our future parallel algorithm. If you are with me, you will not fail to find how much parallel programming is simple and straightforward. Parallel programming is no different from sequential. Probably this one. Serial programming. I guess this one. Sequential. If you have been watching my previous videos listed here, especially those videos listed in this playlist, now is the time to enjoy parallel programming. It's too simple, too easy to miss. Open your working folder. Here we will create a folder 022 thread shape containers. Click this button, thread shape.cpp, hit enter, Ctrl B. You can now close it. Ctrl Shift P, edit configuration JSON. Now we enable newer header files for Intel oneTBB. Here include TOPLEFUN output HPP. If you double-click this link, you can find this PDF book. In Chapter 6, Data Structure for Concurrency, scroll down, you can find this pretty table. We'll be using concurrent unordered map, so concurrent traversal and insertion supported. Keys have a value associated with them. Supported. No visible locking. Lock-free interface. This is lock-free interface. Index operator and add accessors supported. We will learn how to use this concurrent unordered map. Now, talk, play, fun. Superstream, print, auto, L value reference, and add, talk, play, fun, and copy, paste, and L, auto, NL, talk, play, fun, and copy, paste, L, using LT, std, tuple, int. This is call count. Then follows std, vector, std, string. This is for message. We defined LT, tuple with two elements, int, std vector, string. like this. TBB concurrent vector is overkill. This is overkill. We don't need this. This is good enough. Using key T, our key is std thread ID. This is type, thread ID type. Using map T, TBB concurrent map key T, L, T. Of course, we can use unordered map too. It doesn't matter. Void test oneTBB concurrent maps. In the main, we will create a very small application. Context for auto n. We will start with 10. std vector int our vector n. std iora v begin v end 0. We initialize v map t debug message TBB parallel 4. We use TBB blocked range. We pass B begin. This B is this B. We end. We can specify grain size. std size t grain size, for example 2. You can make it bigger later. If you do not provide, default is 1, but I will provide it like this. Here comes, we capture debug map. Now auto range, curly brace, semicolon. I will make a line break here, then like this. Print range size, range size, NL for auto. This is iterator. Range begin iterator not equal to range end plus plus iterator. Why squiggle? I misspelled. Now auto L value reference count message debug message std this thread get id. This is key value, key type, key. We defined key type like this. So I will give you some hint. This is our key type. So it makes sense. The type of thread ID is std thread ID, semicolon. This count is call count. I would say call count. We increment call count. Then message, this message, I would say messages, this, because this is vector. See, LT, first comes call count, then follows SED vector string. So this is vector. In place back, we in place string element of vectors like this. Thomas plus SED to string. This ITR is iterator for vector. This vector, its element is int, so we provide dereferenced. Now, like this. Here, print this debug message and now start clang compiler. cd 022 thread safe containers. Just so you know, I'm using clang 14.0.4 or G++ version 12.1. I'm using the latest version. Clang++ SED C++ 20 thread safe.cpp. Don't miss LTBB 12 or c.exe. Wow, built. I will copy this for your reference. Copy once again, paste G, then dir clsc. Wow! So this is range size. See here, range size. Then we used a single thread ID 1. Then we called 10 times. We called this loop. So Thomas 0 up to Thomas 9. Now I will disable it. We can change the grain size 5. Let's try it. To help you understand what is grain size, CLSC. Now grain size 5. So this grain size or this grain size represent range size. Maximum allowed range size 5. I hope you understand what is grain size. Now we increase to 1000. I guess it's too big, but we can try it. Now we will use GNU. We are testing with the GNU compiler. CLSG. Wow! It's hard to decipher. Don't worry. We use like this. Print debug message size. I say number of threads used. This gives number of threads used. NL. I will give 2 line break. For auto, we use key message. Then debug message. Print thread ID. You can say key NL, or I would use NL. Print, I will use one more. Auto call count messages. Then, sorry, it should be messages. This is message. Please note that this is vector element type LT. LT is tuple. Okay, this is tuple. So this is vector. We print out call count times called, and there I will change it like this. Fixed. Then print messages MSG. I say I'm very sorry. Tuple messages, and there. So if you do not know each type, then we can trace it back. Build again. CLSG. Wow, let's see. It's hard to read. I will give it L. Run again. CLSG. Now goes up. ID 2. 160 times called. It means this thread ID 2 is 160 times called. They are listed here. ID 4, thread ID 4, 63 times called. These are the message. Thread ID 3, 261 times called. The message. You can find all the information. Also, number of threads used 4. You can test arbitrarily 500. Rebuild CLSG. It works perfectly. Now let's try with the Microsoft compiler. CD 022 thread shape containers CL EHSC SED C++ 17 or 20 thread shape.cpp fe m.exe. Hit enter. CLSM. It works perfectly. Only one thread is used. Oh my goodness. We can make it bigger. Like this. This is Microsoft compiler. CLSM. Okay. We can scroll up. 16 threads are used. This thread 746 times called. So I will copy this command prompt here. We can also use nvcc std C++17 like this. Then LTBB 12 on. Actually, we don't need this. CUDA compiler NVCC uses Microsoft compiler internally on Windows platform. Hit enter. It's built. Bingo! This is NVCC CUDA compiler. Also support Intel threading building blocks. So I will copy this, paste it here. Now this is Intel Data Parallel C++ compiler. dp/cpp qsdd C++17 or 20 whatever. Thread. Don't miss EHSC. Don't miss this. F no SQL. It means we are not using SQL. Thread shape.cpp or d.exe. Bingo! D. This is pretty. One thread used. One thread used. Wow. We can something wrong. How one thread used? Let's try. Two thread used. Wow. Very different. So I will copy this. Control Home. Paste it here. You probably wonder how come I use std vector instead of concurrent vector. Because each thread has its own instance of type L. Each thread we used key thread ID, so each thread has different container. So we don't need to use concurrency vector. This is good enough.